Dashboards are powerful tools for visualizing data and gaining insights into various aspects of business performance. They provide interactive and intuitive interfaces for users to explore and analyze data. Here are the key components and features of SAC dashboards: interactive charts and graphs, smart insights, storytelling, predictive analysis, financial performance management, human resources analysis, sales and marketing analysis. Welcome to our walkthrough of the Financial and Cost Impact Analysis Dashboard, a centralized intelligence hub designed to give finance heads, service managers, and operational leaders a clear, data-driven view of how field service activities are impacting the bottom line. We begin at the top with 4 core financial KPIs that act as your control tower for service operations. First, we have the total service revenue, currently at $2,114K. This is your top-line metric, showing the revenue earned from all completed service jobs. For business and finance teams, this figure reflects commercial performance and job throughput. A rise here indicates high customer demand and strong field execution. Next, we have the total service costs, sitting at $934K. This number aggregates technician labor, travel, and operational overheads, the core cost components of your service delivery engine. Monitoring this closely helps finance and ops leaders find opportunities to cut inefficiencies and improve margins. Moving to the spare parts cost, we see $20K. While small in this instance, spare parts can become a major expense over time. Keeping this number lean without compromising service quality is key for procurement and maintenance planners. Finally, we have the travel expenses per job, clocking in at $18,000. This is a critical number, especially for field services that cover wide geographies. It reflects how much you're spending on technician mobility, routing decisions, and overall logistics efficiency. Just below, we move into the profitability percent trend, a real-time line chart that visualizes how your profit margins have evolved over the year. This trend serves as your financial pulse, capturing the fluctuations in revenue versus cost over time. Finance teams rely on this view to track whether cost-saving initiatives are truly improving bottom-line results. Next, this donut chart shows the technician overtime cost per work shift. The morning shift contributes the highest at 28.31%, followed by the night shift at 33.08%, and the evening shift at 38.51%. This suggests most overtime costs are incurred during the morning, indicating a potential imbalance in technician scheduling. Operations teams can use this insight to optimize shift planning and control labor costs. To the right, we have travel expenses per region, a side-by-side comparison of cost distribution across cities. San Francisco shows the highest expense at $5,000, followed by New York and Los Angeles at $4,000, and Chicago at $3K. Houston comes in lowest at $2K. This regional breakdown helps finance and logistics teams identify high-cost zones. These insights can, rounding out the bottom right, this donut chart illustrates the total service cost per service category. The HVAC category leads with 26.78% of the total cost, followed closely by plumbing at 25.28%, electrical at 24.04%, and carpentry at 23.9%. The cost distribution is fairly balanced, but the slightly higher share in HVAC and plumbing may suggest more complex or frequent service requests in those areas. This insight helps prioritize budget allocation and resource planning across service teams. To sum it all up, this dashboard is not just a financial tracker. It's your strategic command center for optimizing service delivery costs and enhancing profitability. It enables teams to move from reactive budgeting to proactive cost control, identifying where you're spending the most, why, and how to improve. Whether you're overseeing budgets, managing technicians, or leading service operations, the Financial and Cost Impact Analysis Dashboard gives you the real-time clarity to drive smarter, more profitable decisions. Welcome to the second key section of our Field Service Intelligence Suite, Predictive Maintenance and Failure Analysis. This is where operations gain foresight. This is where we answer the question, are we fixing problems before they disrupt, or reacting too late? At the top, we begin with your 4 critical KPIs. First, failure rate, currently at 9%, tells us what percentage of service jobs fail due to repeat issues, incomplete fixes, or escalation. It's a signal for operations teams to deep dive into job closure quality and system reliability. Then comes first-time fix rate, which stands at 12%. This reveals how often technicians are able to resolve an issue during the first visit. A higher value here directly correlates with reduced costs, improved customer experience, and optimized technician scheduling. Next, we look at the mean time to repair, MTTR, right now averaging 26 hours. This is the elapsed time from job creation to resolution. Whether it's due to part unavailability or technician delays, this number reflects overall service responsiveness. Lastly, we look at cost per job, reported at $67K. This average cost includes technician time, parts, and logistics. It helps operations and finance teams assess service profitability and explore cost reduction opportunities. Just below, we analyze failure rate across region. This bar chart shows how failure rates differ by location. San Francisco shows the highest at 2.7%, followed by New York at 2.2%. Los Angeles, Chicago, and Houston follow, with Houston significantly lower at just 0.5%. This helps regional leads identify hotspots and prioritize preventive measures accordingly. To the right, we explore downtime per service category in a pie chart format. Carpentry accounts for 27% of total downtime, followed by electrical 22%, HVAC 24%, and plumbing 26%. These insights reveal which types of jobs are causing the most disruption, guiding staffing, tools, and process improvements by category. In the bottom left section, the bar chart illustrates downtime hours per job type. Inspection activities account for the highest downtime at 18 hours, indicating a significant impact on operational availability. Both maintenance and repair jobs show 15 hours each, highlighting consistent delays across these tasks. This breakdown helps operations teams pinpoint which job types are causing the most delays, allowing for more efficient scheduling and resource allocation. Moving on to the cost per skill line chart. It compares average costs per technician skill level, with advanced at $20K, basic at $23K, and expert at $24K. Interestingly, basic and expert levels show higher cost than advanced, which could point to misaligned job assignments or inefficient task allocation. Finally, we examine failure rate, percent per failure reason. Parts unavailable leads with a 3% failure rate, followed by technician skill mismatch and customer unavailability, both at 2%. These reasons provide actionable root causes, helping procurement, workforce planning, and customer coordination teams tackle the right problem areas directly. Filters, such as region and technician ID, make the dashboard flexible. Whether you want a city-level view or want to zoom into Tech 16's performance, this page gives you complete contextual visibility. In summary, this page isn't just reporting field failures. It's about turning maintenance into foresight, so you can predict where things go wrong before customers even notice. Because in service excellence, speed matters, but foresight wins. Moving to the third page, this is your control tower view, the field service summary table. But don't just think of it as a report. Think of it as your command center for operational excellence. Each row represents a slice of your service operations, filtered by model dimensions like job type, job priority, technician name, and customer region. While each metric next to it tells a deeper story about your workforce productivity, service quality, and cost efficiency. Let's break it down. You're tracking average revenue per technician, a direct indicator of how well your resources are being monetized. A drop here could mean overstaffing, underutilization, or unbilled time. Failure rate and first-time fix rate go hand in hand. A high failure rate combined with a low fix rate on first visits? That's a recipe for rework, higher costs, and frustrated customers. This table helps you catch that early. Now look at mean time to repair. Every additional hour adds to downtime, lost revenue, and resource drain. Comparing this across job types or regions gives you instant insight into where delays are creeping in. The cost per job gives you bottom-line clarity. Are you spending too much on specific job types or technician tiers? And then comes the crucial metric, profit per job, calculated dynamically using built-in logic. This KPI tells you whether all the effort translates into healthy margins or hidden losses. Another powerful metric here is the speed score, a composite value representing technician responsiveness. It tells you if service is not just accurate, but fast, critical in SLA-driven environments. And what truly elevates this table is the data action capability. Users can simulate future performance by copying actual values to the forecast version, allowing for predictive planning. Want to see how improved fixed rates could impact profit margins? You can model that right here. Every data point in this table isn't just retrospective, it's predictive. It equips service managers, planners, and finance leads with a single view of truth, enhanced by what-if analysis and scenario simulation. Use this summary to connect strategy to execution, where technician performance, service quality, and cost efficiency come together in one real-time, actionable view. Next, moving to the final page. This is where your field service dashboard shift from tracking past performance to shaping future outcomes. The profitability driver tree is more than just a diagram. It's a simulation model that allows managers to visualize how service efficiency, maintenance, cost, and responsiveness interconnect to influence profitability. Revenue is driven by how effectively technicians are deployed, with higher efficiency boosting revenue potential without increasing headcount. On the cost side, expenses like overtime and spare parts play a big role, where even small savings can significantly improve margins. Service efficiency, measured through first-time fix rates, directly impacts both costs and customer satisfaction. Reliability adds another layer. Reducing failure rates and extending the time between breakdowns lowers service calls and spare part usage. Finally, faster technician response and repair times improve service quality and allow more jobs to be completed, driving profitability further. What makes this model powerful is its interactivity. Leaders can adjust any lever, like reducing spare parts cost or improving fix rates, and instantly see the financial impact. This transforms the dashboard from simple reporting into a simulation engine, enabling predictive, data-driven decisions where every operational choice moves service organizations closer to optimize profitability.
SAC also allows the export of data from individual charts or entire dashboards from SAP Analytics Cloud, ensuring that your data insights are easily shareable and accessible to your intended audience. It is a useful feature for sharing insights and reports with stakeholders who may not have direct access to SAC. We can export into Excel, then show and extract table data into Excel, and finally, export the dashboard as a PDF. Models in SAC define how data is organized, stored, and processed, enabling users to build accurate and insightful reports and dashboards. They support a wide range of features, from data integration and preparation to advanced analytics and collaboration, enabling users to create comprehensive and insightful analytic solutions. They are flexible as we can add additional fields as per the customer's requirement.
For information on these dashboards, KPIs, or required features, please contact VASPP Technologies.